matrix equation without using the concept of the adjudicate and the minors. So now assume that we have been given a linear system in the form A1x plus B1 y plus C1 z. Then we equate this to D1. Then A2 x plus B2 y plus C2 z. So let me write the z that way. Then we equate this to D2. Then we have not C, but A3 x plus B3 y now this we equate this to 3. Assume that we have a system and we are told to solve not by Rama's rule. So other system solve this with other system. So to solve this, we needed to do was to get the determinant of this matrix, and we'll rewrite this in a matrix form. So in a matrix form, this will be A1, B1, and then we have B1, not B1, but A2, sorry, A2, B2, C2, we'll have A3, B3, C3. So all of these we multiply it by x, y, z, then equate this to B1 We put this to D1, D2, D3. So we have just rewritten the matrix, the three equations in a matrix form. Now, if you look at this matrix that we have here, this column here is known as X column. The X column, we'll just use a C. This, the second column here is known as the Y column. So the Y, C. The Y, C, and then this other one is known as the Z column. So the Z, C. Last column, D1, D2, D3. This is known as the constant column. Constant column. The constant column. Now, in our previous way of solving the matrix equation, what we would have done was to get A1, then we delete to get the minus for A1. The minus for A1, so you take A1 and then you delete the first column and the first row, because that is where A1 is, the row where A1 is here. So would have deleted this first row there and delete the first column. So the minus of A1 would be B2, C2, B3, C3. Then we go to B1 and delete again the first row and the second column. So its minus are A2, C2, A3, and C3. So that is how we have got the minus for B1. Then for C1, would have deleted row 1 and column 3. We would have deleted row 1 and column 3. So its minus are A2, B2, A3, and B3. Now that is if we would have been using the other method that we looked at the other time. Now for Cramer's rule, what we do is that now we need to look at each column or each coefficient matrix. So first of all here, the coefficient matrix will be A1, B1, C1, all the way up to C3. So this is the coefficient matrix. So maybe we can rewrite that in the next slide. So first of all, we have the coefficient matrix. The coefficient matrix. Please, I want us to move together. So if I'm not clear, you just tell me so that I can repeat. So our coefficient matrix will be A1 there, B1, and C1. Then we have A2, B2, C2, and lastly A3, B3, C3. This is the coefficient matrix. Then, so this is the first step is to identify the coefficient matrix. Number two, step two, we need to identify the X matrix. We need to identify the X matrix. So now in identifying the X matrix, we will still use the coefficient matrix, but now in the X column. And as I had shown you, let me go back again to that slide. I'd shown you that this is the X column. We have the Y column there, the second one. And then the third column is called the Z column. And then we have the last column there, which is the constant column. So to get the X matrix, now we'll move to column X and replace the elements in that column by the elements of the constant column. So the X matrix, we replace the elements in the X column. So instead of us having A1, A2, A3, we now have B1, B2, and B3. The other values remain the same, so we'll have a B1 there, have a B2 there, and a B3. Then we'll have C1, C2, and C3. This will be the X matrix. So what we have done is that we have only changed the elements in the X column. We have only changed the elements in the X column by the elements of the constant column. So this, we can call it dx. So we'll find the determinant of the X matrix. We'll find the determinant of the X matrix. So we'll come to that later. Then step 3, we get the Y matrix. Y matrix. Now again, in the Y matrix, we still use the coefficient matrix, but now in the Y column, that is where we will replace the elements in the Y column with the elements of the constant column. So dy again will be given by, so the other values remain the same. So still we'll have A1, A2, A3, But now in the Y column, now we'll have D1, D2, D3. Then in the Z column, we'll just have a C1, C2, and a C3. Then we have the Z matrix. So maybe we can divide this into two. Z matrix. The Z matrix again, DZ will be given by the other values of the coefficient matrix remains the same. So we'll have A1, A2, and A3. Again, B1, B2, B3. So the elements in the Z column now is what now will replace by the elements in the constant so B1, B2, and B3. Then now remember, we will be using the Cramer's rule to solve the equation. So we need to get the value of x. So to get the value of x, x will be equal to now ex, that is the determinant of the x matrix, divided by d is the determinant of the coefficient matrix. Y will be given by dy, which is the determinant of the y matrix, divided by d, the determinant of the coefficient matrix. And lastly, z will be given by now dz, divided by the determinant of the coefficient matrix, which is d. So that is how to go about the Cramer's rule. So unless there is an area that you want me to clarify, we can look at an example so that now we see practically what we are talking about hypothetically. So can we continue? Are you able to hear me now? Okay, so we can look at an example and then to now highlight on what we are talking about and see it practically. So assuming that we have a matrix in the form, now I can write it down there. Assuming that we have the equations x minus 8y plus z, then we equate this to 4. Then the other one will be negative x x plus 2y plus z, then this we equate it to 2. Then we have x minus y plus z. We equate this to 1. So assuming we have those equations, sorry, this is negative 1 here, and this is 2z. Sorry for that. So 2z there, then to negative 1. So the first thing that we should do, we write this in a matrix form. So we'll have 1, then we have negative 8, then we have positive 1 there, negative 1 there, positive 2, 1 there, 1, negative 1. So we have 2 there, our coefficient matrix, so this will be our the determinant D, get the determinant D, just a D, this will be equal to, we take 1 first, slowly. Okay, we take 1 first. This one here, the first element. So we need to cancel or to delete row 1 and column 1. So its minus will be 2, 1, 2, 1, negative 1, and then 2. Those are its minus. Then minus. Then we move to this other one, which is negative 8. So please remember the signs there. Minus 8. Its minus r. Now, because it is appearing in row 1 and column 2, so we'll delete row 1 and we also delete column 2. So its minus are negative 1, 1, 1, 2. So minus 1, 1, then 1, 2. Those are its minus. Then we add, so plus 1, this third element here, 1, again because it is appearing in row 1 and column 3, so we delete row 1 and we delete column 3, so its minus are its minus are -1, 2, 1, -1. Yes, so that is that. So to get the determinant of this, now what we'll do is that we'll first of all factor this. We get the determinant of this. So the determinant, first of all, we multiply the elements in the leading diagonal. So 2 times 2, that will give us a 4. Then minus the elements of the other diagonal. So that is -1 times 1, which is -1. So a minus and a minus becomes a plus. So 4 plus 1, that will be 5. 5 times 1, that will be 5. Okay, then we continue. This other one, so 5, then minus, so we work this one out. Again, 2 times -1, that becomes a -2, minus 1 times 1, which is 1. So -2 minus 1, that becomes a -3. A -3. A -3 times -8. A negative times a negative becomes a positive. 8 times 3, now that becomes 24. So that is 24 there. Then we continue. The other one is we multiply the elements in the leading diagonal. So -1 times -1, that is a +1. Then minus 1 times 2, that is +2. So we are having 1 minus 2, that is -1. So when you collect the like terms, the negatives together, -24, we add it to -1, that becomes -25. Then plus 5, that will be -20. So D is -20. I hope we are together up to that point. I hope we are together up to that point. Then we move to dx, and remember what we said. Oh, Rita is asking where we are getting -8. Now, if you look at our equation, if we rewrite it in a matrix form, we will have 1. The value of x here, if I use these equations here, the value of x here is 1. The value of y here is -8. The value of z there is 1. Then when we move to row 2, the value of x here is -1. The value of y there is 2. The value of z in row 2 is 1. Then row 3, the value of x there is 1. The value of y is -1. And the value of z here is 2. So this is where we are getting the coefficient matrix, which is coming to our D here. So the negative 8 is this one here. So to get the determinant, first of all, we'll take 1 times its minus. And the minus that we are talking about here is not a negative sign. It is the minus of M-I-N-O-R-S, the minus. So the minus of 1, we will delete row 1 where this 1 is appearing, and then we delete the column where it is appearing. So its minus will be 2, 1, negative 1, 2. Then when we go to negative 8, again, we delete row 1 where it is appearing and column 2. So its minus are negative 1, 1, 1, 2, which we have written here. So when you are getting the determinant, we take 1, then minus this other value here, negative 8 times its minus, and then plus 1 times again its minus. I hope now you have seen where we are getting the negative 8. The negative 8 that we have there is the same as the negative 8 that we have there. Okay, so can we go to dx? So first of all, we said that to get dx, we will use the coefficient matrix, but now we change the x column with the coefficient, the constant column. So what we'll have there will be, now for dx, we change the x column by the constant column, and the constant column is this. So we'll have 4, 2, negative 1. Then these other values are the same. So we'll have minus 8 there. Sorry. Minus 8. And then we have 2 and a negative 1 there. Then the last column, 1, 1, 2. The other values will be the same. So now to get the determinant of x, now the dx, again we follow the same procedure. So we start with the first element here, which is 4 times its minus. So 4 is appearing in row 1, so we delete row 1, we delete column 1. So when we delete row 1 and column 1, now its minus will now be 2, 1, negative 1, 2. Then minus, then we come here. The element that is appearing next is negative 8. Negative 8. So again, it's minus. So we delete row 1 and column 2. So its minus are 2, 1, negative 1, 2. So 2, 1, negative 1, 2. Then plus, the next element here is 1. So is 1. Then we get its minus. So 1 is appearing in row 1. So we delete row 1 and we delete column 3. So its minus are 2 and then 2, negative 1, negative 1. Then we can now expand. So first of all, we multiply, we start with this minus here. The elements in the leading diagonal, 2 times 2, that becomes a 4, minus negative 1 times 1, that is negative 1. So again, a minus and a minus becomes a plus. So 4 plus 1 is 5. 5, we multiply it by the 4 here. So that will be 20. Then we move on to this other one. 2 times 2, that is 4, minus negative 1 times 1. Negative 1 times 1, that will also be negative 1. It is by a coincidence that they are like that. So this 4 plus a minus and a minus becomes a plus. 4 plus 1 is 5. 5 times negative 8. So this will be 20 minus, then negative 8 times 5, that will be minus 40. Then we move on, plus negative 1 times 2, that is minus 2. Then minus negative 1 times 2 again, minus 2. So again, a minus and a minus here becomes a plus. So negative 2 plus 2, this becomes 0. 0 multiplied by 1 is 0. So plus 0. And this will now be equals to 20 minus minus 40. That will be plus 60. Any question up to that point? Because I want us to move together, please. Any question? Are we okay? Or is there any other area that needs clarification? Yes, any area that need clarification? Okay, so we can move on to dy. Again, remember we are using the coefficient matrix. We are using the coefficient matrix. So in the coefficient matrix, we'll use all the other elements except the elements in the y column. So if we are using all the other elements, we'll have 1, negative 1, 1. Then now in the y column, we replace those elements by the constant coefficient, which is now 4, 2, 1. Then the last element is the same, 1, 1, 2. So then again, we find dy, the determinant, same procedure. So we start by the 1 there. 1 times its minus. So we delete row 1 and we also delete column 1. We'll have a 2 there. 1, 1, 2. Then minus, the second element is a 4. So 4 into, then we delete row 1 where that 4 is appearing. It is appearing in row 1 and in column 2. So we delete row 1, we delete column 2. So what we'll have here is negative 1, 1, 1, 2. Then plus the next element is 1, the 1 there. So this one is appearing in row 1, column 3. So we delete them. So what we'll have is negative 1, 1, 2, 1. Yes, Nyamu, I'm seeing you typing, and I can't read your what you are typing. Okay, is there any question that you have or any clarification? Okay, so we can continue. So we expand this. So we have 2 times 2, the elements in the leading diagonal. That will be 4, then minus 1 times 1, which is 1. So 4 minus 1 is 3. 3 times 1, that will be 3. That will be 3. Now minus, then we move to this column here, the next minus 2 times negative 1, that is minus 2. Then minus 1 times 1, which is 1. So that will be negative 2 minus 1, which is minus 3. Minus 3 times 4, that is minus 12. So minus 12 there. What we have done, we have first of all expanded this. So we have multiplied 2 by negative 1 to get a negative 2. Then we subtract now the product of the other diagonal, 1 times 1. So minus 1, that is negative 3. And that negative 3, we have multiplied it by 4. Because already this minus sign here, we add it here. So that will be that. Then in this other minus here, to expand it, we'll have 1 times negative 1. That is minus 1 minus 1 times 2, which is 2. So negative 1 minus 2, that is minus 3 times 1, that will be minus 3. That will be minus 3. Remember, a minus and a minus becomes a plus. So if you collect the like terms, if you collect the like terms, now dy will now be, you now add 3 plus 12, which is 15, minus 3. 15 minus 3 is now 12. Any question on how we've got the dy? Okay. So dx, we got dx as 60, dy as 12. Now we can move to dz. So we can move to to the next slide. So dz, again, we use the coefficient matrix, except now in the z column, we'll replace the elements there in the z column by now the constant column. So we have 1, the other elements are the same, 1, -1, 1, then -8, 2, -1, then the last column we have 4, 2, -1. So what we have done is that we have only replaced the z column elements by the elements in the constant column. So to get dz now, we take 1, the same procedure, times its minus. So we delete row 1 and we delete column 1. So its minus are 2, 2, -1, -1, then minus, minus. Then we go to the next item here, which is -8. So -8. So 8 is appearing in first row, second column. So we delete them. First row, second column. So we'll have -1. We have a 2, 2, 1, -1. Then plus the next element there is a 4. So plus 4 into, so we delete row 1, column 3, where it is appearing. So its minus are -1, 2, 1, -1. Then we expand. So this will be equals to -1 times 2, that is -2. Then minus, now -1 times 2, that is -2. So again, a negative and a negative becomes a plus. So this will be -2 plus 2, which is 0. 0 times 1 is 0. Then minus, continue, -1 times -1, that will be 1. Minus 1 times 2, that is 2. So 1 minus 2 is -1. Then times -8. -1 times -8. So again, a negative times a negative becomes a plus. So that will be +8. So 8 there. Then plus, move to the last one. -1 times -1, that will be 1. Minus 1, 1 times 2, that is 2. So this will be 1 minus 2, which is -1. Negative 1 times 4 is minus 4. So what we have here is minus 8 plus minus 4, and that will be minus 12. So dz is minus 12. Remember, we had worked out dx to be 60. Dx 60. We had also worked out dy. I can show you the other slide. Okay, not that one. So we worked out d as negative 20, dx 60, and dy as 12. So if we move on, so dy is 12, but d, we found out the d as negative 20. So with this now, we can comfortably find the value of x, y, and z. So x is given by dz, dx divided by d. So this will be equals to 60. Dx is 60 divided by negative 20. So what will that give us if you divide? What is the quotient? 60 divided by negative 20. Yes? Members, are you lost? 60 divided by negative 20. 60 divided by negative 20. I want us to move together. Yes, you should also be active. We are doing this together. Okay, Juliana, that's okay. Negative 3. Mutai Kamau, negative 3. Brenda, negative 3. Rita, negative 3. That is okay. Then we move to dy, not dy, but the value of y. So y will be given by now dy over d. So this will be equals to now dy, which we found as 12, divided by d, which is negative 20. So again, what will that give us, members? 12 divided by negative 20. Okay, so you can also report it in a fraction form. So 4 divided by 12 is 3. 4 divided by that is 5. So this can be minus 3 out of 5. Minus 3 out of 5. Or negative 0.6. That is okay. So even if you leave it in this form, there is no harm. Then lastly, z. Z now is given by dz. Dz divided by d. Dz is negative 12. So what will be the quotient? Negative 12 divided by negative 20. So what is the quotient there? Yes, what is the question? What is the question there? Members, are you asleep? Okay, positive now because a minus and a minus, they will cancel. So we'll have 12 divided by 20, which is 3 out of 5. Rita, I hope it is a typing error. Okay, you have corrected that, 0.6, that is okay. So that is how we can use the Cramer's rule to solve an equation. Remember all the steps that we have gone through. So any question up to this point? Any question? So what we have said is that if you are to use Cramer's rule to solve an equation, first of all, you'll have to identify a coefficient matrix. Then you identify the X matrix, the Y matrix. So depending on the order, remember in this case, we are looking at a 3 by 3 matrix where we have 3 rows and 3 columns. You can even use the Cramer's rule to solve a 2 by 2 matrix, because now you'll only have the X column and the Y column. So dx will now be, you just change the elements in the X column alone. dy, you change the elements in the Y column. So if there is no further question, I think we can move to our discussion forum. So I'll create one there so that we do an example that is there. But I'll be online to look at what you are doing. So I'm just ending this live session. And again, I've recorded the live session. So I'll post